Today we're going to show you an example of thermal expansion. The materials you'll need are a flask and this thing, this little contraption here, with a stopper, a glass tube, and a thermometer. We can measure the temperature and the water will go up in here. And another material we have that you don't really need, but it's easier for you guys to see what we're doing, is food coloring. So the first thing you want to do, go to the sink with your flask, take the thing out first, and fill this with water. Get it just to the right spot, right where it goes up here, like that. Looks good enough. Then, you want to put your food coloring in. One drop's obviously going to do it. Let it do its thing. Spread all out there. Then you're going to put your stopper in with the glass tube and the thermometer. Like this, right? So the tube touches the water. After that, you're going to go over here to your heating thing, heating pad by Flynn Scientific. And you're going to turn it on low. Just so it doesn't boil and explode. I'm going to wait.
So what I'd say,
our hypothesis is if the temperature rises, then the water level might rise too.
So as you can see, the water in the tube went up a tiny bit, and the temperature we are on is still on 1. So we're just going to wait. Maybe turn it up a little bit.
so what you'll do is you'll have to start thinking about like, you're already narrating.
And what we're going to measure with is our measuring stick.
Okay?
And we're going to measure it
You
by
gotta think about
centimeters.
Okay, everybody's gotta say at least one thing. Somebody can talk more than the other.
So, yeah.
Everybody's
It's
gotta say
about
one thing.
Not even 1 inch, really. Or centimeter.
Huh?
Maybe just turn the temperature up a little bit more.
Go through that, like editing it, and 'cause I want you to talk about your experience and also connect it to the main thing that you're talking about class.
You can kind of see the tube fogging up, like it's getting hotter.
It hasn't really.
And the water kind of slowed down a bit, just the way the food coloring moves in it. And there's bubbles sort of rising. But water is not yet filling the tube. Wait. It is a little bit. So the food coloring didn't help at all, but you can see the water going up.
About 6 centimeters, I guess. It's really hot.
About 6 centimeters, maybe 5. So you can see it really moving, sort of.
It's going up.
And you can kind of hear it,
What is it?
like, sizzling or whatever.
Something is burning.
So why?
Something's burning.
We can talk about that. When we do it, right?
So the water is really traveling through there. And it's really sort of boiling at the bottom. You might want to turn it down a bit.
See, the air bubble is keeping it separated. I think that's why we
About
have
9 centimeters now.
So it's about 9 centimeters.
Yeah.
It's grown quite a bit in the past 4 minutes.
it's got a little more.
Not even 4.
But yeah, I think a big part of it, you know, yellow.
So a good thing to think about is how this would apply to real life.
We did it again, and we got it to work. That's, I think each time we've done it,
It's up 10. Almost 2
almost basically, right? That makes sense?
So it's at 10 centimeters now. Right?
It's
That's
almost
at
like
11. So our hypothesis was right. If the temperature rises from this, then the water level will rise too, which obviously it's rising quite a bit.
So what we'll do is next time we'll do it without food.
Let's see how much.
Okay? We'll do just with water. But for now, you can
13 and a half.
13.5 centimeters.
This won't be doing.
We're gonna see if we could get the water level a little bit more to the top. Right now it's at
16.
16. It was at 15. So you can sort of see it slowly rising. If it weren't for me moving. It's almost to the top. As you can see with the thermometer, the temperature rose too. And it's right at the top, so we're going to stop it. We don't want it to bubble over. And yeah. So now, after we got it all the way at the top, it's slowly going down, but we're going to put it into this cold water just so you can see how dramatically fast it can go down. Not really fast, but you can see it drop. It's going down. It's going down.
Lots and lots of going down.
Lots of going down in this town so far. Very, very slowly.
Stationary.
We have a guest.
Hey, what's the starting one? What? I don't know. What?
So if you use a cold temperature or colder water, the pressure that had made it rise will automatically go down, even if it takes a little bit longer.
Wait, at the beginning? Yeah, wait, that's down. Why are you speaking, Hope?
And you can sort of see like steam from the contrast of the temperatures on the flask on the inside.
Hey, what did the student try eating?
So that was our experiment.
Did it work?
Yeah.
Sweet. Awesome.
And now we're going to clean up and get the water out of here. And hopefully that gave you a basic understanding of just how thermal expansion works.
So basically, thermal expansion is the expansion of length, area, and volume as temperature changes. This happens through heat transfer whenever a substance is heated. The kinetic energy of the molecules increase. That causes the molecules to move and separate. Solid materials tend to keep their shape during thermal expansion. A lot of architecture is based around thermal expansion. Bridges are built to expand and go back to normal during the process of thermal expansion. In this picture, the train tracks are all uneven because of thermal expansion. It's an engineering fail.